All right, today we are going, you guys know that on Friday we did cylinders, right? So we're basically going to do what we did for cylinders with prisms today. And a lot of it is going to feel very, very similar because it's very, very similar. All right. A prism is a polyhedron with exactly two congruent polygon parallel faces called bases. Okay, again, the bases must be congruent and parallel. The other faces are called lateral faces. Lateral meaning sides. And they're going to be parallelograms. So we talked a little bit about if it was like a right prism. What? Did I not put two on your table? Okay. I think I forgot to pause the video. Awesome. Cool. Okay. So remember that if we have a right, like a we're going to come back to it. Okay, each pair of, okay, if it's right and oblique, right? Okay. So if it's right, they're going to be rectangles. If they're oblique, they will be parallelograms. Obviously, rectangles are parallelograms, but they're more specific. Okay, each pair of adjacent lateral faces has a common lateral edge. The lateral edges are parallel segments. Okay, would you see if you can label the bases? Okay, so the bases are like this surface, right? And this surface, those are bases. Okay, lateral edges are these. Okay. These are our lateral faces. Now, you can see that each lateral face obviously has a perimeter, right? But when we are talking about the perimeter in these formulas, we are typically talking about the perimeter of the base. And the perimeter of the base is special because it is the number of sides times how long the sides are, right? Does that make sense? The number of sides times how long each of the sides, okay. At least for the bases that are regular polygons. Sometimes we'll have like a base like this where it might not be regular, so you would just have to add them up. Some of our triangles aren't regular, so you would have to add those up. Okay, any question about this vocab? All right, let's talk about surface area. Recall that for a cylinder, when we had our net that this dimension was the height of our cylinder. And then this little dimension wraps around my circle. So it's actually the circumference. So this is our C, which was 2 pi r. You can see something very similar is about to happen here. Okay, so if we're looking at the surface area for a prism, we're going to have a rectangle here when we fold out our prism into a net, and we have our height, and then this is just the sides of our base added up to give us our perimeter. So instead of the circumference of a circle, well, if it is a regular polygon for the base, it will be the number of sides times the side length. Okay, that gets a little bit more exciting if all the sides aren't the same length, then we just have to add them up individually. Okay? Right. So basically, we have the same type of thing. Instead of the circumference, though, it will be the perimeter of the figure. But the circumference is like the perimeter of a circle anyway. So we kind of already know how to do this. Okay. So our lateral area is going to be our perimeter. Let's do that a lowercase p because it's a linear dimension. Sorry. Our perimeter times our height, that makes our rectangle, plus how many bases? Yeah. So here's a B, there's a B. Why are the B's capitalized?
It's an area.
Yeah, they're already two-dimensional areas. Okay, perfect. Okay, oops. I did this one, didn't I? Sorry. The lateral area is just the rectangle. I started thinking about surface area. Okay, the surface area is the lateral area plus the two bases. Sorry, I'm just still, like my wheels are spinning from running around like a lunatic. So the lateral area is our perimeter times our height plus 2 of our bases. Now, the big B is going to depend on, is our base a parallelogram? Is it a rectangle? Is it a triangle? Right? Volume is a lot easier. Volume is just going to be the big base times the height. Okay, let's start with some really nice, easy examples. Okay, we have a Kleenex box that is a rectangular prism measuring 5 by 3 by 5 by 3.5 by 3 inches. Okay, a Puffs box is also a rectangular prism measuring 6 by 3 by 2.5 inches. Which tissue box is going to hold more tissues? If I'm asking about their capacity inside, am I asking about surface area or volume? Volume. Okay, so here I have a rectangular prism, so I'm just going to do length times width times height, right? Because the length times width is the area of the big base. Do we need to draw a net? Or let's just draw a picture. How about that? We'll just draw a picture. Can everyone do their best attempt at a Kleenex box? Okay. So I picked my longest dimension as 5. Then we have a 3.5 and a 3. I mean, it's not perfect, but more or less, right? For a rectangular prism, does it matter which two parallel congruent faces I make be the bases? No, because in a rectangular prism, this one and this one I could use. I could use this one and this one, or I could use the bottom and the top. Which pair would you like to see be the bases? The bottom and the top. Fine. Okay, so we're picking these to be the bases. So what is the area of our big B? Yeah, 3.5 times 5. Okay, what is volume? Big B times little h. So by default, this is our h. Correct? So my volume has to be 3.5. Oops, that looks like 3 times 5. 3.5 times 5 times my height of 3. Isn't that just length times width times height? So you can think of it either way. You can think of it as like it's my big B times my height, or it's my length times width times height, right? That's the nice thing about a prism. All right, what do you guys get for the volume of the Kleenex? Okay. 52.5 inches cubed. All right, what about the puffs? So the volume of the puffs, 6 by 3 by 2.5. Thank you. 45 inches cubed. So which one holds more tissues? Yeah. Okay. So that's volume of a rectangular prism, length times width times height, or big area base times linear height. All right, we're leveling up. Have you guys seen one of these Toblerones? Okay, we're finding the volume and the surface area of a Toblerone box that has a height of 9 centimeters and a triangular equilateral base whose sides are 4 centimeters. Now, the picture is really important. Are they telling us the height of the triangle? Okay, so this is sat. Do you guys see that this is the way that this is sitting? It's resting on one of its lateral faces. So just because it's sitting on a particular face does not make that face the base, right? Okay, you have to look for which of my two sides are going to be parallel and congruent, and in this case, that's my little triangles, okay? So these are the bases. Everybody see it? So this 9 centimeters goes along the height of the prism. And then these are all 4, 4, and 4. Now, I've given you your cute little equilateral triangular base. So, do you guys, in order to find the area of our base, which we need for the surface area and the volume, do you guys realize we need the height of this cute little triangle? Okay. So, we've done this a lot in our previous unit. We're dropping a perpendicular because we need to know the height. Now this is a different height than that height, so be careful. So if this whole thing is 4, then this piece has to be 2. And we've got a 30, 60, 90, right? Because this was an equilateral triangle. We've done a million of these, right? It is 2 root 3. So the height of the triangle is 2 root 3. Okay, so if you can imagine the net or the package, it should be 3 rectangular faces and then these 2 little equilateral triangular bases. So for our rectangle, we have the height of the prism, which is what? 9. And then we have the perimeter of our cute little equilateral triangle right here. So each of these is 4. Does everybody see that? So the whole thing is 12. So our surface area is our lateral area plus 2 of our bases. So our lateral area is 9 by 12 plus 2 bases. Now our bases are both triangles. So you have to think about what is the formula for the area of a triangle. And it's 1/2 times the triangle base, which is 4, right? Times the triangle height, which we found out was 2 root 3. So what I'm seeing is that this 2 and this 1/2 are canceling each other out and making a 1. So our surface area ends up being 108. Is that what I heard you say? Okay, plus 8 root 3. These are centimeters squared. Can we round it to the nearest hundredth, just to practice that? $132.77? Okay. 132.71. Sorry, 232.71 centimeters squared. Okay. Okay, please tell me we're done. No? Oh, okay. I have to do the volume. Okay, the hard part is over because I've already found the area of my base, right? I already have my base. That's this piece. This is my B. Right? So my volume is my big B, my base, 1/2 times 4 times 2√3. This is big B. Times the height of the prism, which is 9. I'm getting 36√3. So approximately 62.35. Thank you. And this will be centimeters cubed. Okay, questions? All right, here we go. All right, guys, this time we're finding the surface area of the rectangular prism with a length of 5 centimeters, a width of 9 centimeters, and a volume of 495 centimeters cubed. Okay, so we have a prism like the tissues. You didn't know you were going to art class today, did you? Ooh, ooh. Some of us never passed art. Hey, you're not supposed to laugh at my prisms.
Jesus.
Hey, do you need to take a minute?
I think I'm good.
Okay. All right, so I have a 5. I have a 9. What am I missing? Okay, so I don't know the H. Do I need the H to find the surface area? Yeah, so what can I use to find the H? The volume. So I can use the volume and work backwards. So I know that volume is length times width times height, right? For a prism, rectangular prism. So I'm going to put in all the stuff I know. I know the volume is 495. I know the area of my base is 45. Length times width is 45. What I don't know is the height. Divide it away. Divide away the 45. Is it 11? Got it. All right, we won't have to draw this every time, guys, but just until we get the hang of this, let's make a net. So our net is going to be a little goofy looking. You're going to have a rectangle where 2 of the faces, oh shoot, I've already messed this up. 2 of these are 5, and then the other 2 are like 9. Does everybody see what's happening if I like stretch this out? They kind of go 5, 9, 5, 9. Does that make sense to everybody? What just happened? Okay, and then I need my lids. Wait a minute, can I do that right? Okay, what we just figured out is that this is 11. Whew. Okay, did I get that right? So we've got a bunch of different pairs of rectangles. Okay, what is the area of each of these rectangles? They have a 5 and an 11. 5 and 11. You see that these are all 55? Does that make sense to everybody? Okay, what about this one? Yeah, these two are 99. Okay. What about these orange ones? If you fold this back together, so this is 5, what's this side if it has to lay right here? Yeah, this is 9. Everybody see that? So these two are both 45. Yeah. Yeah. So if you think about, okay, well, how do I do this so that it's fast next time, and maybe I don't have to draw this whole big picture? Do you see that I'm going to have to do, this H is now 11, right? I'm going to have to do 2 5 by 11s, 2 9 by 11s, and 2 5 by 9s. Right? You just have to pair each of them up and double it. Does that make sense to everybody? 2 5 by 11s, 2 9 by 11s, and 2 5 by 9s. We can handle that. All right, what does that total make? What total does that make? What? Okay. Did you say 298 or 398? 398 centimeters squared. Okay, how do you feel? All right, cool, we're still going strong. All right, I want you to take a look at the number 4 and see what you think. Why? The bases look different. Yeah, okay, so if you are finding the area of this base, it's 1/2 times 8 times 5, right? Oops. 8 times 5. And then this base is 1/2 times 5 times 8. Does it matter what order the 8 and the 5 go in? Multiplication is commutative, right? So these two actually have the same base, okay? And as long as they have that same cross-sectional area, which they appear to because these sides are all parallel, then they will have the same volume because their heights are also the same. Does anybody remember what the name of this principle is? Starts with a C. I think it might be Italian. It kind of sounds like our mascot. Yeah, Cavaliere's principle. Okay, so because these two triangular prisms have the same base, they have the same height, they have the same cross-sectional area at every point along that height, by Cavaliere's principle, they will have the same volume. I'm not writing it out. I need you to write it down. I'll say it again though. Because our two triangular prisms have the same base area and the same height and the same cross-sectional area at every point along that height. By Cavalier's principle, they have the same volume. I just did this little thing with the coins again, where we made the cylinder, the right cylinder. I'm doing this for the video, leave me alone. And then the oblique cylinder that has the same volume even though it's slanted. Can't really see that. There we go. Okay. I don't know that we have to do all of number 5. I would just like to talk about maybe a misconception for number 5. Okay, as far as finding the volume of this goes, it's easy because you have the base of the triangle, you have the height of the triangle, and you have the height of the prism, right? So that's not the hard part. The tricky part that I would like to talk about really quick is the surface area. When I look at this, it is really tempting for me to think that this is an equilateral triangle base. Do I have any information that tells me it's an equilateral triangle base? No. So you got to be careful with those kinds of assumptions. So if we're looking at the surface area, we do not know what this side and this side are, correct? Actually, we don't even know that those sides are congruent, so we can't even find the surface area, so we're going to skip this problem. Okay, we don't have to do it. You're welcome. All right. I know you guys were like, oh, when are we going to find the area of hexagons again? Today. It's today. Yay. So, do you guys need to take a minute? Okay. Can you get it together? Okay. So in both our volume, which is our big B times little h, and our surface area, which is going to be our lateral area plus 2 big B's. In both of those, we need to find the big B, right? So can we focus on that first? Okay, so I know that each one of these sides is 8. Okay, so do you remember partitioning this into a bunch of isosceles triangles? Okay, tell me what this central angle is. 60. And when I chop it in half, when I drop a perpendicular bisector, I get a 30 and another 60. So I have a 30, 60, 90. So what is this little bit? 4. Okay. Somebody tell me what this little apothem is. 4√3. Okay, so the area for our big base is going to be how many little triangles? 6 triangles, so just 6 for the end. And our apothem is 4√3, and our side length is 8. Okay, so we're going to have 6 congruent triangles, and each of them is 1/2 times the base, which is the side length, 8, times the height, which is the apothem, 4√3. Okay, so we're going to get a lot of mileage out of this. Can we simplify this? (96√3). Okay, that's going to be our big B. All right, let's start with the volume. Volume is big B times little h. So that is 96 root 3 times 12 feet. Let's do exact on this one. Can we do exact? Well, what? 1,152 root 3. These are cubic feet. Okay, now our surface area has two of the big B's, and then it also has this rectangle. Tell me what this dimension on my rectangle is. 12. This is the height of my prisms. Yeah. Okay, so each of these, each of those is 8. 8, 8, 8, 8, 8. How many of these do I have? 6. I have 6 times 8. Okay, do you see that this is just my N times my S? This is my perimeter of my base. Oh, I wanted to make that a lowercase p. Does everybody understand where that is coming from? Okay, so if I want to talk about surface area, I mean, you could think of it as like you have 6 8x12s. You see what I'm saying? Right? Okay? You can think of it in a lot of different ways. So I like the 6 8x12s, but that's just me. Okay, and then we have 2 bases. All right, this is our N, S, and H. And this is our P. Let's just call this perimeter times height. All right, so what's 48 times 12? So this is our exact surface area, and this is feet squared.